Hey, geometry. Here we go with 2.5. We're going to talk about the triangle sum theorem today. Big one. But before we jump into the triangle sum theorem, we need to talk a little bit about triangles, different types of triangles that there are. So this is 2.5, the triangle sum theorem. So first, before we jump into triangles, here are the different kind of types of triangles. I can classify triangles in two different ways. I can classify them by angles. So what type of angles are in there? And there are four different types of triangles when you classify them by their angles. So first I could have a right triangle. A right triangle has one 90-degree angle. A right triangle has one 90-degree angle. Looks like that. I could have an equiangular triangle. An equiangular triangle has three equal angles. Equal angular, meaning equal angles. Three equal angles. You could also have what's called an acute triangle. Might look something like this. An acute triangle has three angles in it, and they're all less than 90 degrees. Three angles, all less than 90. Technically, an equiangular triangle is also an acute angle because those all end up being smaller. And then the last one is called an obtuse triangle. So an obtuse triangle has one angle that is more than 90 degrees. I'm going to just move that up here so I have a little more space. There you go. So that is an obtuse triangle. So if I say, look at that obtuse triangle over there, you guys would know which one to look at. That's kind of the goal in classifying like this. But I can also talk about triangles based on how long all of their sides are. Here I only have three. Let's see. Triangles by sides. I have three here. They might look like this. Like this. And they might look like this. Okay. And these three types, so I have what's called a scalene. All three sides are different. No congruent sides. You could have an isosceles. Sorry, that's a C. Isosceles. ISOSCELES. Anyway, two congruent sides. Or you could have, similar to equiangular, from here, equilateral. All right, very nice. Equilateral. Lateral, kind of like a lateral pass. In football is like to your side or behind. Lateral sides, like latitude and longitude. Sides. Three equal sides. Okay, so a triangle can be right and scalene, or equiangular and equilateral, or acute and scalene. So you can be two of both things because they're looking at different parts of the triangle to classify it. Now, on to the namesake of today, the triangle sum theorem. And a little bit about how it's used. The triangle sum theorem says all of the angles inside of a triangle, no matter what size it is or type it is 180 degrees. The sum of interior angles, inside angles of a triangle is 180 degrees. This is a big one. We're going to use this a lot. The sum of a triangle, of all the angles inside of a triangle, is 180 degrees. So, for example, one example of how this could be used. Say I have this triangle here. Let's say this is 80, and this is 2x. And let's say this is an isosceles triangle. If it is an isosceles triangle, then these two like base angles will also be the same. So my question to you is, what's x? What's x? So in order to do these types of problems, we're going to have to set up a equation. So if they all three angles here add up to 180 degrees, and these two are the same, then can I say that this is also 2x over here? Yeah, totally. So now, and I always set up my triangle sum theorem like this, especially when I was like missing an angle, just like take your time with it. All three angles. There's always three angles in a triangle, no matter what. Mistakes I've seen people do here is like, if there's a right angle, they'll forget the 90. Or if one's not labeled, they'll forget that one, or usually things like that. Or sometimes they'll do, if there's angles outside of the triangle, they'll use that one instead. Just three angles in a triangle. I'm going to go 80 plus 2x plus 2x. Okay, let's combine like terms and solve. So this is 80 plus 4x is 180. Subtract 80 both sides. 4x is 100. Divide both sides by 4. X is 25. Now, does that mean this angle is 25 degrees? No, not necessarily. If it were just x in that corner, yeah, but it's 2x. So let's call this angle R. Let's find the measure of angle R. So 2x, x is 25. So the measure of angle R is 50 degrees. Okay, that's how the triangle sum theorem is going to be used. Now, I also have, in addition to the triangle sum theorem, like a close cousin of the triangle sum theorem. We actually used it to prove this one. Is called the exterior angles theorem. And this one, a little bit trickier to see, but it's definitely smoother to use. So let's say I have a triangle formed like this. And this is angle A, This is angle B. And let's say this over here is like angle 1 inside that angle. Notice that 1 is the same over here or over here. Okay. I guess I should put this though, like inside A, B. They're inside those two, inside the triangle. Just to make sure we know exactly what angle you're talking about. So the exterior angle theorem has to do with this, relating this 1 to these two. So notice that I've got a triangle here, right? You've got a triangle, and a triangle adds up to 180 degrees. So this angle in the corner, A and B plus that, has to equal 180 degrees. And it makes a linear pair with angle 1 over here. So these two also have to add up to 180 degrees. And because of that, if the sum of these two, A plus B, is equal to 1, because they both have to add up to 180. I'm going to write this like in an official way. If the sum of two non-adjacent the sum of two adjacent angles is equal to the exterior angle. And this is your exterior angle here, number 1. So let's see, a little example of that could be something like this. Let's say this is 70, this is 20, and that's X. Find X. Absolutely, you could find out that this angle in here is 110 and then use the triangle sum theorem. Totally. That will 100% work all of the time. Triangle sum theorem is one of the most dependable theorems there are, I think. But the exterior angle theorem says, here's a shortcut. Angle A plus angle B equals angle 1. So in this case, X plus 20 is 70. Shortcut. Subtract 20, X is 50. And let's just check that real quick. If this were 110, 110 plus 20 is 130. 130 plus 50 is 180. So the triangle sum theorem works as well.